In this video, we're going to talk about a theorem about limits. So basically, this theorem stating is that the limit of f of x as x approaches a, that equals L, our value L, if and only if the limit as x approaches a from the left of the function equals L, which is also equal to the limit as x approaches a from the right of that function. Okay? So basically, it's saying that the limit has to exist at L, right, or as x approaches a, at a to L if it approaches a from the left and right. All right, so the best way to show that is with a little example here. And so let's say we want to show that the limit as x approaches 0, that being our a here is 0, of the absolute value of x is in fact 0. I want to show that using this theorem above. Okay? Well, we know, we note here, we know that the absolute value of x, all right, is equal to, we can write it as a piecewise function, x if, all right, if x is greater than or equal to 0, and it also equals negative x if x is less than 0, okay? So it behaves just like these two functions. So what we can do is use each one of these functions, all right, from the right and the left to show that both sides approaching at x equals a equal that L, okay? And L in our effect in this one is 0, okay? So since the absolute value of x equals x for x values greater than or equal to 0, our limit as x approaches 0 from the right of absolute value of x is equal to the limit as x approaches 0 from the right of x, which we know to be 0. Okay. The limit, deal with the other side, the limit, all right, of x, the absolute value of x as x approaches 0 from the left, we know behaves just like the limit as x approaches 0 from the left of negative x, which is equal to 0, because in this one, we're dealing with the absolute value of x is equal to negative x, right? Stated here above, when x is less than 0, okay? So here we've shown, we can see that from the left-hand side, the right-hand side, that the limit approaches 0, and here from the left-hand side, it approaches 0 as well. So therefore, by our theorem, we can state that the limit, in fact, of x approaches 0 of as x approaches 0 of f of x, which is the absolute value of x, is in fact 0. The graph of this function, of the absolute value function, looks like this, right? And we can see here that if we approach this value here, all right, that's 0, from the right, the positive values, it's approaching that 0, and then from the left, it's also approaching that 0. Since they're both approaching from both sides, we can say that the limit, in fact, is 0. I hope this video was informative, and thank you for watching. Please subscribe to our YouTube channel, as well as on Twitter, Facebook, and Instagram. Thank you. Have a good day.